Hey guys, now let's work with the fourth problem here. A little interesting, just because we're going to use another theorem here called Pythagoras theorem, and we'll see why are we using that. All right, so let's read the question. It says the find the length of the chord which is at a distance 6 centimeters from the center of the circle of radius 10 centimeters. So let's say that is the center of the circle, and that is the chord km. All right, and it is at a distance of 6 centimeters. So it means this perpendicular distance from the center to the chord is 6. That's given to me. So I can write the length of CL is nothing but 6 centimeters. Okay, what am I supposed to find out? The length of km, which is nothing but my chord. All right, that's what's required. And what else is given to me? I can see he says the radius is 10 centimeters. So what is the radius in fact? Radius is nothing but the distance between the center and any point on the circumference. So let me choose this point. Why is it? Because I already have it, right? See what happens if I choose that. I can just join these two guys. Right, if I join these two guys, exactly, yeah, right. What I get is a triangle here. Okay, I know that that is 90 degrees. Very good. So from this triangle, let's say from the triangle KL and C. Okay, we know that KL is perpendicular to CL, right? KL is perpendicular to CL. It means what? The angle KLC is what? It means the angle, measurement of angle KLC is 90 degrees. Good. So that makes KLC a right angle triangle. So why am I working on it? Look at that. I know that this length is 10. That is given to me. I know that this length is 6. That is given to me. And if I find the length KL and double it, I'll get the length of km. So that is why I'm looking for this triangle. All right. So why is that? I also know from the first property that if at all CL, which is perpendicular to the chord and it is drawn from the center, I know that L would be the midpoint. It means KL will be equal to km. So only thing I have to do is to find KL and double it up. You'll get the value of km, and what is that I'm looking for. All right. So based on this, based on that thing, so I just draw the triangle here. This triangle is what I have, and I know that is 6 and that is 10, and that guy is like K, and that guy is like L, and this guy is like C. That is it. Can you find this guy somehow? Yes. Pythagoras says that if that is a triangle and that is 90 degrees, the hypotenuse squared, that is KC squared, right? KC squared will be equal to the sum of the squares of the other two sides. It means KL squared, okay, plus CL squared. So that's what it is. So can I substitute the values here? I know what is KC, that is 10 squared, and what is KL? I'm looking for that. So let's KL be there. And what is CL squared? That is 6 squared. So that is 6 squared. So can I solve this guy? That's like 100. It's like KL whole squared as like 36. Put this guy on the side, you get KL squared is 100 minus 36. That goes like 64. And KL is square root of 64. Right? Why is that? Simply because of this. If I have a square, I can remove the square and put a square root on this guy. So that goes like 8. Right, what is this value 8 we got? We got KL is below 8. Let's try to put it here and say. So I understand that KL, what I get is 8. Right, now I know that if KL is 8, even LM is 8. Why is that? From the which property? From the first property, which says if CL is perpendicular to KM, then I know that KL would be congruent to LM. Right, so I can just write that KM, that is a full length, is nothing but twice the length of KL. All right, so the length of KM is twice the length of KL, so that is 2 times 8, which will give me 16. That is it. So I understand what I was looking for is the length of the chord, which is nothing but KM, which is, I got it as like 16. So length of KM was 16 centimeters. That's all about it.